to continue our discussion, so we have our midterm topics. Will start with the slides of Manans, or the Saccharomyces cerevisiae, which is the main source also of the mannose. Okay, so epimerism. When a sugar are different from one another, configuration with regards to a single carbon atom other than the reference carbon atom are called epimers. So epimers meaning glucose and mannose are epimers which differ only in respective carbon atom too. So in specific na what we call this one, difference is only at carbon atom. So pwede siyang tinatawag na epimers. Okay? Or single carbon atom difference between two sugar group. Okay, so we have glucose and the mannose. So usually they have what we call this one, epimerism, that takes place in carbon number 2. So this is carbon number 1, 2, 1, 2. So this one is the reaction from the base. Okay, kung base siya, that is basic. Okay, so that is between the glucose and the mannose. So the epimerism between the two are found in the carbon number 2 of the mannose, and also rotation is just the structure of mannose is just a rotation of the second of the OH at the second carbon atom. Okay, so D-fructose is also an isomer, but this one in the second carbon atom, it undergoes the oxidation process, wherein it turns out into a ketone group. Okay, so this is not a epimer, this is an isomer. The D-fructose is an isomer of your D-glucose during the oxidation reaction process, at the same time dehydrogenation and removal, of course, of the hydrogen atom. Okay, next. So epimers of D-glucose, D-glucose, we have carbon number 2. This is your D-glucose, epimer at carbon number 2 of D-mannose. At the same time, D-galactose at carbon number 4. So when you say epimers, it's not just in a second carbon atom, but in a specific carbon only. So it refers only to one carbon atom, wherein a different structure of that monosaccharides have a different position of the hydroxyl ion. Okay, galactose, for example. Okay, so this is carbon number 1 from the aldehyde group, 1, 2, 3, 4. This is an aldose. So the rotation of your glucose is to rotate it to the other side, okay, to the left side. And this one, carbon number 2, nag-rotate naman yung OH group of the glucose into the other side, okay, or the left side, making it the D-mannose. At the same time, this one is the galactose. So in the familiarization structure, try to look at the epimers or the isomerism of each structure, of the monosaccharides. Okay, so anomerism, D-glucose crystallize at room temperature at a fresh solution is prepared. So this one, we have to use the polarimeter in the lab. Okay, usually we do this one in quality control. Okay, in your third year, I think, third year subject. Okay, so that is the examination, of the structure. So specific rotation of polarized light is 112 plus 112 degrees Celsius, but after 12 to 18 hours, it changes to plus 52 degrees Celsius. Meaning, when there is a change, of a polarized light, okay, rotation based on the change of temperature. So the change in rotations with time, at the same time, it changes also the temperature, is called mutarotations. It is a change of optical rotations that occurs by epimerization. Kung saan epimerization, nagkaroon ng rotations between the third, second, or fourth carbon atom. Okay? That is the change of equilibrium between two epimers when the corresponding stereocenters interconvert. So this is interconversion. Okay? Cyclic sugar shows mutarotation at alpha and beta anomeric, that is considered to be interconvert. Okay? When we say interconvert, so there is a ang anomeraism refers only to the alpha carbon rotations of the OH group or the functional group. Okay? So you try to look at the beta. So this one is to the left side, and we have alpha D glucose at the right side. Okay? So this is just rotation. If you have this is a Fischer projection writing the structure, and this is Howard production writing of the structure of that glucose. So try to see, it is beta D glucose. Usually the OH are found at the position that's the upper part, while in alpha D glucose at the lower part at the alpha carbon atom. So take out yung anomeraism refers only to the difference of the positions of the functional group, hydroxyl group, at the alpha carbon atom. Okay? Okay. Example, this one. There are called anomers. Okay? New asymmetric. So this is not asymmetrical position of the carbon atom. Refers to anomeric carbon atom. So anomer with the OH to the right is the alpha to the right. It's alpha D glucose. While the other OH to the left is known to be the beta D glucose. Okay, so this is the rotation. So once nag-rotate siya to the left or to the right, so pwede siyang sabihin natin na right is alpha and left is called beta D glucose. So it is found at the first carbon atom of the alpha carbon atom. Okay, so fructose is a ketohexoses. So fructose keto group is found at the second carbon atom, wherein your D glucose undergoes the oxidation at the same time the hydrogenation process, removal or rearrangement, of the structure, which leads to the formation of D fructose. And D fructose is also a isomer of your D glucose. Okay, like mannose, galactose are isomers of the D glucose. So D glucose, when you draw the structure, is only the D glucose. Okay, yung pinaka basic na dapat yung tandaan po. Okay? So fructose have similar molecular formula with glucose but different structural formula. So that is known to be a isomer or the stereoisomers. Okay? D fructose, actually that is levorotatory. So fructose remains predominantly as furanose ring. Okay, this is considered to be a pentameric or cyclic. Okay, this is known to be a cyclic organic compound. It is also major constituents of honey. Okay, so we have D ribose. Okay, and we have the beta D ribofuranose. Okay. D glucose optical symbol was defined as D glucose, the configurations, which meant L fructose was also D fructose. Okay, L fructose is known to be a levolose in laboratory. Laboratory, hence prefix is D. Okay, this is laboratory. So the older name of fructose is levolose, that's why it's tawag sa L levolose, but also it is D fructose. After laboratory property of rotating plane polarized light to the left, in contrast to glucose, which is dextro-rotatory. Okay, so for us you to know that L fructose was also a D fructose. Okay, fructose kasi levolose na yan. Okay, next, reactions of monosaccharides. In indiol formations, in mild alkaline solution, carbohydrates contain free sugar group. With aldehyde, a keto group will tautomerize to form indiols or indiols. So meaning there's a formation of a double bond or the alkene group where 2 hydroxyl is attached to a double bond. So meaning sa indiol formations, there is what we call formation again of the natawag natin na indiol, which is known to be the double bond. Okay, diol is alcohol because of OH. Glucose is converted to fructose and mannose. Indiols are highly reactive. Sugars are powerful reducing agent. Why indiols? Because of the double bond. It is very reactive, di ba? Unsaturated bond. Cupric plus sugars, it will form mixtures of carboxylic acid by breaking the double bond of the indiols. Okay, so tautomers are constitutional isomers, or the mirror images, compounds readily interconvert by chemical reactions. So, tawag doon is not constitutional. Okay? It is not mirror images. It is interconvert, by chemical process to correct. So, with enol group, this one, to keto form, or lactam form to lactine. Okay? So, this is lactine already. And we have the amide form to imidic. Amide kasi ito, dalawa. Once isa na yung bonding dyan, that is considered imine or imidic. Amine form, and we have the imine form. So, once in each, that is amine form. So, Libre-de-Bront, transformation of glucose, presence of the oxidizing agent. So, this one, we discussed already in the epimerism property of the structure of that glucose. So in the in the presence of oxidizing agent, so example is a base. Usually glucose is converted to a ketone. That's why I told you it is in the process of oxidation, at the same time dehydrogenation. So this is oxidation process. Like mannose, it is interconvert or converted to D-fructose by oxidation and dehydrogenation. So there's a removal of the hydrogen, at the same time addition of oxygen by the process of oxidation process. So this is the presence of base. So take note, the reactions is considered to be reversible reaction. So D-fructose to D-glucose, or D-glucose to D-fructose, D-mannose to D-fructose, and D-fructose to D-mannose. Okay? So kung reverse naman yung reactions, that will lead to hydrogenation or hydroxylation process, formation of D-mannose and formation of D-glucose respectively. Okay? Next. So Benedict's reactions. Benedict's test reaction is very commonly employed to detect the presence of glucose in urine, known as glucosuria. Okay, usually this is employed to diagnose diabetes mellitus patients. So content, we have sodium bicarbonate, copper sulfate, and sodium citrate. So during the Benedict's reaction, copper sulfate sugar group, so the copper sulfate is reduced to copper or to cupric oxide, and cupric dioxide to cupric oxide, while Indial oxidizes to sugar. Okay, so this is the mean. So once again reduce siya, it will reduce copper sulfate to cupric oxide. So this is the product, so reducing agent. So meaning once reducing sugar siya, i-convert ang copper sulfate to cupric oxide. Okay, that is the reducing sugar. So oxidizing, yung inindiol, pwede siya i-convert into sugar. Okay. Next, ozone formations. All reducing sugars will form ozone with excess phenylhydrazine when kept into boiling temperature. So there are crystalline formation known as ozone crystals or ozone formations. So usually with the use of phenylhydrazine sa laboratory, you can see this one through low power or high power objective in the microscopic examinations. So sunflower shape, the petal shape, or maltosazone. And we have hedgehog. So usually in lactosazone, you can see this one, lactosazone, or in galactose. Okay, pin coating pins on needle shape or glucosazone. Okay, this one is known to be a needle shape. So Molish test. All carbohydrates, monosaccharides gives a rapid positive test. So disaccharides and polysaccharides react slower because of the higher of the large amount or the large amount of molecular, or based on the structure of polysaccharide and disaccharides. So they cannot react easily because of the high molecular weight. Okay, this test is useful for identifying compound which can dehydrate to furfural to hydroxymethylfurfural in the presence of sulfuric acid. Okay? So furfural, a sister chemical increasingly popular hydroxyfurfural or HMF molecule, regaining attention. Usually ito yung ginagamit sa productions of bio-based alternative for the production of everything from usually production of antacids, fertilizers to plastics and paints. Okay? The presence of purple color between test layer of sulfuric acid indicates the positiveness of carbohydrates in Mulich test. So oxidation of sugars, so mild oxidation, so sugars plus bromine water plus or water, this aldonic acid. Glucose is oxidized to glucuronic acid, mannose to mannoronic, galactose to galacturonic acid. Okay? Strong oxidation, so we have sugars, for example, mannose, glucose plus nitric acid heat, it will form a saccaric acid. Okay? So reduction of alcohols, aldose plus sodium amalgam, it will form alcohol. So glucose to sorbitol, mannose, mannitol, fructose, sorbitol, and mannitol, galactose, dulcitol, ribose, and to ribitol. This is an alcohol already. That is reduction process. So example yan, we have glycerol, erythritol, ditritol, ribitol, diarabitol, disilitol. Okay? And we have here dialitol, sorbitol, mannitol, galactol, talitol, and dieditol. So this one are examples of product of the reduction of sugars.